Okay, so now we're talking about thumb motions, function, and the anatomy. So we have thumb radial abduction, abduction, thumb radial abduction. Take your hand, put it on a hard surface, maybe on your laptop in front of you, and do like a karate chop. So the pinky side is down, and the rest of the it's kind of upright. Karate chop on the table. Take your thumb, put it all the way down, and then bring it up towards your face. And it should look like his thumb right here, kind of like a hitchhiker's thumb. He's also flexing his digits. You could just leave them extended. We're just talking about this thumb motion from here out to here as he hitchhiker. Looks like he's coming back from Las Vegas after a long weekend or something. But that hitchhiker kind of motion is thumb abduction. Abductor pollicis longus. There's the anatomy. It's very long. The longus goes way up onto the ulna there, ulna in the radius, and it inserts on the first metacarpal. It's a radial nerve, backside of the hand. That's thumb radial abduction. And then palmar abduction. If you take your hand, so you have the back side of your hand, and put the back side down flat on the table. And then put your thumb right on your palm and kind of come towards your face again. This one's really hard to do, just talking you through it. We'll do it in the lab. But that thumb palmar abduction, which is different than the radial abduction, she's kind of doing it here, abducting her thumbs as she plays the piano. She does use the abductor pollicis brevis. So that's the brevis in there that abducts the thumb that way, median nerve. See how it attaches to the scaphoid in the trapezium and comes up, inserts on the proximal phalanx of the thumb, the MP joint. So that's palmar abduction, abductor pollicis brevis. Thumb adduction. So they're coming back down. So if you think of the hitchhiker, you're just coming back down to the side of your hand. They're kind of adducting their thumbs as they shake their hands. Adductor, ADD, pollicis is the big one for that. MP extension. Remember there with the thumb, there's just the MP in the IP joint. There's no DIP. So here's the MP, which is the knuckle of the thumb. And that pulls back. When you're doing the hitchhiker, you're extending the MP. Extensor pollicis brevis. Extensor pollicis brevis is the MP extension as the text. It looks like a really old-fashioned text thing. But as you text on your phone, you're using a lot of MP extension with that pollicis brevis, and IP extension as well. Right there, that's an example of extending the IP joint. Extensor pollicis longus. There it is again. Goes way out to the tip of the thumb because that distal part, it has to extend it up. And then we have the flexors, IP flexion, flexor pollicis longus, and MP flexion, flexor pollicis brevis. So you can kind of categorize these into your brain. Flexor pollicis brevis is MP because it's closer down. Flexor pollicis longus is the IP, it's further away. And it's the same reverse for the extensors. Extensor pollicis longus for the IP, for the extensor because it's way out. And then extensor pollicis brevis for the MP because it's closer. Then we have this motion called opposition. There's a lot of functional uses to it. If you take your hand and you touch tip to tip, so the tip of your pointer finger to the tip of your thumb, kind of like they're doing right there, tip to tip. Then you go to the next finger, the tip of your thumb, tip to tip, your ring finger, tip to tip, and then your pinky finger, tip to tip. Two big muscles do that. They're not that big actually. The opponens pollicis and the opponens digiti minimi is one of my favorite names for the pinky. Digiti minimi does the opposition from the pinky tip to the thumb tip, and then the opponens pollicis does the other three, getting to that thumb tip. And there they are. There's the opponent's pollicis and the opponent's digiti minimi. And here's just a graphic on the motions again, the MP flexion and extension, and then she's doing, or he's doing opposition to the pinky with the digiti minimi.